in listen-only mode.
Hi everyone, welcome to today's webinar on peroxide former management. My name's James and I'll be your moderator for today's event. Before I turn things over to our speaker, I just want to run through some housekeeping items and give you a brief overview on what this webinar is going to entail for those of you that might not have attended one in the past. So we'll start with a slideshow presentation providing insight into how to manage peroxide formers in a streamlined and cost-effective way. You'll also learn how to create and implement a peroxide former management plan and see how other institutions have rectified their peroxide former problems during our case study portion. Following the presentation, there will be an open Q&A period. You can ask questions anytime throughout the webinar by typing them into the questions pane on the right-hand side of your screen. Please note that everyone's microphones will be turned off for the entirety of the webinar, but if you do have a question or a technical issue comes up, you can use that questions pane to communicate as well. Finally, please keep in mind any and all unanswered questions will be addressed and followed up on via email after the presentation, but we'll do our best to get to as many questions as we can with the time that we have. You'll also receive a copy of the slide deck and the recording tomorrow, so you will get a copy of all the materials that are presented today. Today's speaker, Ted DeVille, is the New England Quality Manager at Triumvirate Environmental. This is where he heads the Technical Lab Services Division and Company Reactives Program. Ted has over 16 years of peroxide former and high-haz management experience. And with that, I'll turn things over to Ted. Hey, Ted.
Thank you, James. Good morning, everyone. Thank you for attending today. Today we're going to be discussing peroxide formers. We'll discuss hazards, the most common peroxide forming chemicals, different resources in chemical hazard recognition, give guidance around recognizing the material, some of the do's and don'ts for handling these materials, where the regulations come into play for management of these materials, any regulation requirements for these materials. Then we'll get into how to implement and maintain a management program, some of the components to that, training, setting up a program for discarding, giving a brief outline to implementing a successful program, and then get into some success stories as we get into the case studies. As the peroxide formers, certain peroxide formers, and there's a handful of common peroxide formers, such as ether, tetrahydrofuran, that we commonly come across, that will over time and will become a hazard to health and safety. There's a lot of documented cases out there where primarily ether and tetrahydrofuran are the two most common that we see as having incidents. Either through age of the containers, just storage, improper storage, in the back of a flammable storage cabinet, in a lab, in the back of a shelf, or also when they've been run through distillation units and then stored, and also when they've been run through a rotovap as well. Those are the three most common instances where we run into solvents forming peroxides, and they just have not been managed properly. So some of the peroxide formers, potential energetic materials, potential peroxide formers, will over time will really form peroxides through the oxidation process, slow oxidation process, as air is introduced to the system. You get different hydroperoxide chains that can become explosive if not properly handled. Some of the potential peroxide formers will come with inhibitors. Butyl hydroxytoluene and BHT and hydroquinone are the two of the more common ones that we see. But also over the last few years, we've seen a trend within research where they've kind of moved away from the different solvents with inhibitors and they've gone to inhibitor-free formulations, which kind of pushes up the timeline if the material is not managed properly because there's nothing inhibiting any peroxide formation. And a big part of this as we get into the presentation, it's really about how the material is stored and a frequency in which it's checked in. If there is a timeline for the peroxides, a check-in or some sort of structured management program, you can really reduce the potential for peroxides to be forming in any of these chemicals. Either they'll get used up or discarded before any peroxide formation. From a recognition side of things, as the materials age, there will be, there can be a physical change. A lot of the, primarily solvents they're all clear solvents. Sometimes they'll get, over time they'll start to get cloudy. You'll see crystal formations floating inside the solvents in some cases, or sitting at the bottom of the solution. Over time, we've seen it all three of those ways. Then there's also some solids that can form peroxides, sodium amide being the most common. And as that forms peroxides over time, it will start to change color. And that's an excellent indicator prior to handling the material if something's going on with the chemical. So any physical change is kind of the first trigger to something going on. Next, I think we have a small poll question that we wanted to run by everyone. Just take a few moments and just kind of give your input, and we'll kind of answer or build part of the presentation around some of the answers that you give for what your greatest need in terms of peroxide former management is. So you take 30 seconds to do that.
Yep, so I just launched that poll. Everyone should see the options there, from training or identifying peroxide formers to developing an SOP, tracking and labeling, and material removal and disposal. So I'll give you just a few more seconds. It looks like almost everyone has voted. Okay, so looks like number one, 38% chose training and identifying peroxide formers. 2 was tracking and labeling at 26%, and 3 was material removal and disposal at 21%. So there you go. And then 16% was developing an SOP, Ted.
Okay, excellent. Thank you, everyone. And try and touch on all of those throughout the rest of the presentation. Previously mentioned some of the common peroxide formers, ethyl ether and tetrahydrofuran. 2 others that the most common ones that we run into in forming peroxides, and it is a long list, but isopropyl ether and 1,4-dioxane. So those 4 are really the most common solvents that we see, that I've seen out in the field as forming peroxides, and we come across at client sites. From a solid standpoint, and I mentioned this a little earlier, but sodium amide is the most common solid and one of few solids that will be able to form peroxides. But potassium amide is another one, but sodium amide is the most common. We do see that on a fairly regular basis. It'll either be a white or a gray powder. But as it starts to form peroxide, it'll turn yellow. Then it'll get darker yellow. Then it'll get a brown. Then when it's very concentrated peroxides, it'll get extremely dark, a dark brown for that. So that has only seen a handful of sodium amides getting that dark. Commonly, we'll come across and able to dispose of them as it's starting to turn from the white to the light yellow. As the peroxide formers oxidize, get the hydroperoxide chains, the material can become shock sensitive, and there's a few different ways that the material could potentially be set off. It could be just, could be heating it up, running it through, through a rotovap, or it could be putting it down in a bottle, putting it down on top of a lab bench with some force. If there's crystals, peroxide crystals underneath a cap, potentially opening the material, or if there's crystals going up the side of the bottle. Any shaking like that could potentially set the material off. Before handling, taking these stimuli into account, the handling of it is extremely important. And that first recognition piece, which is the age of the material, and how, if you can see into the container, how the material looks. Those are kind of your first two parts to go through from a recognition standpoint. IDing was one of the things that was mentioned in the poll. The age and how it appears, part of it. Then also the way the material has been stored, taking into account whether or not the material has a peroxide inhibitor in it. Over time, the inhibitors will break down upon exposure to light, heat, and air. If the material is not inhibited and it's exposed to those conditions, it's going to be more likely to form peroxides. So from an ID standpoint, those are your first three steps you want to go through before handling the material, because there is the potential to that the material could be set off if it does have concentrated peroxides. This is a picture of a tetrahydrofuran bottle that we came across in a lab cleanout. It was in the back of a flammable storage cabinet. It's an older bottle. You can only see part of the label, but it is an older bottle. It did test for 150 parts per million of peroxides in there. That was one that, when we came across it, had to, didn't move it. Had to come in and handle that separately. As you can see, there's crystallization at the bottom of the container. And the first part in the evaluation on our end was that visual inspection. As soon as we saw something in the tetrahydrofuran bottle, noticed that the bottle was older, put it off, didn't touch it, worked around it, and planned for the next step. This is another picture of tetrahydrofuran. We came across this one tested for 50 parts per million of peroxides. Over the last few years, tetrahydrofuran has really been accounted for 85 to 90% of the jobs that we've done for peroxides stabilization. Everyone has what we found is everyone's very aware of the hazards around ether. Ethyl ether, it's widely documented, widely known. Seems like the researchers we come across, everyone's very aware of that one. Tetrahydrofuran is lesser known, widely used much more than ether, and it's the one that we're seeing is kind of slipping through, that people aren't really catching. That's the most common one that we've come across. Next, this one was an unknown solvent that came across in a lab cleanout that we didn't move, we didn't touch. Immediately, as soon as we saw this one, we just left it alone and put together a plan on how we were going to handle the material. We ultimately ended up coming out and taking the material out of the laboratory, taking it out of the building, and testing and stabilizing the material. As you can see, there's a lot of crystallization in this material. This one was stored for years, just within the lab. It was exposed to. It was in a warm area of the lab. It was out in the light. Not sure if it ever had an inhibitor in it, but this is the crystallization that came across in the container. I mentioned sodium amide earlier. This is a picture of a sodium amide we came across, and again, in another lab clean out we did. There's some crust on the outside. The material had been spilled on the outside and started to react off on the outside of the container. This was a lab clean out for a professor that was leaving the institution, and this had been stored for 30 years was the estimate. This was one that again came across it in the fume hood, left it off to the side, didn't move it, put together a plan, and ultimately came in and stabilized this material. When we get into the handling of it a little bit, there's different steps for the organic solvents versus a sodium amide. We'll get into in a little bit. When this container was opened, when we opened it, it was a dark brown on the inside. So it was heavy peroxide concentrations on the inside of that bottle. Again, which makes sense. It's been stored there for 30 years. Wasn't a surprise when we saw that coloring. So those are some of the initial steps, or some examples that I've seen out in the field, and when we've had materials that have peroxides in them. The next part, and a common question that I receive is, what regulations govern this to help get people to follow a management program? And there's really no clear regulations that say you have to manage peroxide formers in a certain way. It really falls under the OSHA General Duty Clause, which an employer is required to safeguard its employees. There is some guidelines out there. The NFPA has some guidelines. And then if the material is old and turns out to have peroxides and needs to be handled as a potential explosive, certain states are going to get involved or need to be brought into the picture to allow for treatment permits. Up in New England, 5 out of the 6 New England states require state approval for treatment. They go above the standard RCRA, treatment in tanks and containers. And again, Connecticut and a lot of the Mid-Atlantic allows for treatment in tanks and containers. And start to move south. Maryland does request a permit, working with the state. As you move down the East Coast, most of the states allow for tanks and containers, treatment in tanks and containers. And speaking with North Carolina, they request a permit, but and as you move west, most of the states allow for treatment in tanks and containers, don't require a permit. One thing that I have encountered, even though there's no requirement for notification, it's been requested by fire departments, local fire departments, to be made aware of these situations when they come up. And that ties to partially to the relationship the institution has with the fire department, but we've had cases where it wasn't required. The client was unaware of any notification requirements, and the fire department afterwards requested notification just so in the event of an emergency, they would be able to respond and know what they were responding to. Along with the NFPA guidelines, there's safety council guidelines. There's different lab safety manuals that outline management, but again, no clear regulations for it. In the event of, or whenever we need to do these treatments, regardless of state or permit requirements, we always are doing them off hours in a secure location within the institution, just to minimize the foot traffic. And then we'll isolate all the areas that are going to be affected by where we have to, as we move the material through the building. So it can be, blocking off hallways, elevators, parts of buildings, just to get the material out the door, and then having a secure location. We don't have to worry about delivery trucks or foot traffic or any cars coming in. So it can be, as a guideline, rule of thumb, that's the best way to that we manage the material. And from an identification and stabilization process, as we go through it, we're really asking a lot of questions on the front end, and again, tying to the ID comment before. You do that visual inspection initially. You determine the material needs to be handled in a safer way, or could be potential explosive. We're looking for a lot of information. What the material was being used, how it was being used within the institution, how it was being stored, approximate time, different information, any information at all. Sometimes we've run into cases where researchers are trying to create a new chemical or a new long-chained chemical, and this is a byproduct of it. So those are all things that we need to know on the front end so that we can determine the most appropriate way to handle the material. In some cases, we've had to use trade journals or recipes with general chemistry knowledge to determine how to properly handle the material. Diluting the material is a common misconception. If you have a peroxide former, just diluting it down does not remove the peroxides. All you're doing is separating the solvent and the peroxides, and actually you can concentrate the peroxides and make it actually more of a hazard because you're concentrating those peroxides. So dilution is not the answer. So to get all that information and make that determination on the front end is extremely important prior to handling the material. These are all steps that we go through before we handle anything in working with our clients. So it can be very labor intense. It's off hours. It can be very inconvenient to do any of these stabilizations of the material. So the way in which to avoid all of this is through a management program. 95% of all the remote openings that I do can be avoided if the material was managed under a system and was properly, checked in upon every few months and was disposed of when the time came, as opposed to it sitting around for years on end. So 3 things I commonly see, mentioned the long-term sitting around, also improper storage, mentioned that no preventive maintenance, but also big one that we see, and I think a lot of places have, and researchers have gotten better with this, but the bulk purchasing, which we still do see a fair amount. That's just buying it just because it may be cheaper, and then it's not used and it sits around with the intent of it being used at some point, and then next thing you know, 3 or 4 years go by or longer, and the material still has never been touched, and it may not be properly stored, moved around a bunch of times. Who knows? Those are things that, if monitored, can all prevent any remote openings. The biggest challenge, and every institution is different, it's really what's going to work for you. So to kind of develop a standard SOP that kind of will capture everything, capture a proper management system so that you can remove the material before it becomes a stabilization and a remote opening event. So again, that developing that can be difficult, and every institution is going to have different ways of doing it. Hopefully, what we'll go through now is kind of a guideline that can be adapted for your program. The biggest challenge is collecting the information and tracking it. There's been a couple, in working with some of the clients, we've had success with getting the researchers involved by getting their input and making them part of the solution, making them aware of the issue and part of the solution. In some cases, we've had other cases where the clients have, we've worked with our clients and researchers to get inventories of the laboratories. We tie it to reporting requirements, to Tier 2 or fire department notifications, flammable storage inventories, which are all required. Been able to tie it in through that with the researchers' help, or we've been able to just help the client just go into the laboratories, inventory, and set up a tracking system by laboratory for our clients so that they know what material they have on site. The regulatory requirement and fire department notifications has been one that's been very helpful. So once you get through that tracking piece and determine what's going to work, is it, as an environmental health and safety group, can you do that inventory, set up that tracking system, working with the researchers, or having, in some cases, we come in and helped our clients with the inventory piece to kind of kick that off and help manage it. Once we've set up that, you've determined that system, the next part would be to set up a timeline on how often the materials are going to be checked upon. It could be some institutions have every 3 months, some are monthly, some are every 4 to 6 months, some are annually. Again, it's going to depend upon the materials, how feasible it is to, the size of your institution is going to impact that, and how often you can dedicate resources to doing those testing. And the other part is the volume that you're seeing, or the amount of solvents, potential peroxide forming solvents that you see. Another way that we found has been successful is central purchasing, which we don't see very often. But when that can be controlled, you're able to minimize the amount of material that's bought at a time. You're able to track when the material was received, and you can track how long it's been on site from that information. And that's been successful. But again, it is something that is on the lesser side. We don't see that too often. There's only a handful of places that we currently see that central purchasing system set up. But if you have that, it could be something that would work for you. Many of the goals ultimately can, once the program started, could be maintained with, depending upon the size of your group, it could be maintained within the existing staff once you get that program up and running, which is usually the most difficult part. But once you determine the best way to do it, the best system for tracking that's going to work, and kick that off, after that the program will keep education of researchers up, and the environmental health and safety group can help manage the program, and the program will essentially run itself. We'll keep up with the training. It can be, talked about the central purchasing already, but the training piece with the if it's written into the chemical hygiene plan, as researchers go through if chemical hygiene plan applies to you, or lab safety protocols, training people to those when they first come in, refresher trainings, keeping people up to speed from that side of things can help minimize any potential materials lingering for too long, be able to manage it that way. Another part is, you have that set program, but then there's that maintenance piece. In a lot of cases with the training, the program will run itself, but there does need to be a kind of a check and balance. So having the labs inspected periodically, make sure that they're maintaining their materials in a timely fashion. It's not lingering along for too long. We do, currently we partner with some of our clients to do those periodic inspections. In some cases, our clients do their own periodic inspections, and if they have anything in question, they'll ask us to come in for, to review the material and to check in on it, or to get our input on it, or they may ask us to just come and take it away. There's a couple different ways to do it, but that maintenance really has been very successful for all the clients that we're working with on this. The other part of collecting the information, once you get the researchers to do it, a format that's going to work is in an Excel spreadsheet. Is there a homegrown database that you can collect all the information? Whatever will work best for you. In some cases, some institutions have a web-based form. Along with the chemical inventory, whenever they receive a peroxide form, they have to notify environmental health and safety that they received the material, and there's a form that they fill out with the notification, what the material is, when it was received, catalog number, CAS number, all of that, so you can tie, exactly what's in there, the size of the container. All that's tied into it. An email sent off to environmental health and safety. They're aware of the material now. They know to keep an eye on it. So it can, forms, inventories, it's really, there's a couple different ways that we've seen programs work, that we've helped implement programs for our clients. But it's really, whatever is going to work best for your institution is something you'd have to determine. So the biggest thing is, the lab can never have too much information. I mentioned before that everyone has a very good understanding of the hazards of ether, but they may know that ether is bad, but not necessarily know why or what contributes to the peroxide formation. They may just know that ether can explode, but not really know why. They may not really know, and this is one where tetrahydrofuran is one that's often overlooked from what we've seen, and that's been reflected in the amount of remote openings we've been doing for tetrahydrofuran to treat contaminated THF. Getting involved in the lab meetings is something we've found a lot of success with, going through and to help educate lab people, work with the lab personnel, get them involved, kind of talk it through, see what will work for them, see how it can help. And along with that, it helps with getting any potential safety issues out on the floor so that people are aware. There's no mystery for handling the chemicals. A couple of the case studies now that I'd like to kind of get into are within, are company-wide, all the way, from Boston down to the Mid-Atlantic area. Some of the some examples of clients that we've worked with to kind of streamline and develop a program management system that and they've been very successful. One up here is in the Boston area, is a large university. We started off doing annual walkthroughs. We moved it to semi-annual, every 6 months, and now we're doing quarterly walkthroughs of all their laboratories, evaluating and inventorying any potential high hazard materials, bringing it back, presenting that, putting a report together, presenting it to environmental health and safety and to the researchers, talking with the researchers and working with them. If it's something that is okay now, but they've stopped doing a experiment and they no longer need the material. In a lot of cases, they've just said, I don't need it anymore, and we take it away. We've been able to eliminate any remote openings as a result of the walkthroughs. It's been very successful. As the program's grown, we've been able to get any potential materials off-site, really stay on top of it, and working with environmental health and safety, we're able to actually eliminate any remote openings, which has been a huge cost savings, which is an added benefit. Next is this is one example of the central receiving, where everything gets entered into a chemical inventory database upon receipt. Know exactly what the material is, where it's going, when it was received. Do walkthroughs through the laboratories, periodic walkthroughs through the labs. And then also once a year, we're running the report, the inventory report, and flagging any materials that are still that appear to be still on site and that are in the inventory. And we'll go to those labs, check on the material, evaluate it, and remove it for disposal. Again, this has been a very successful program where we've been able to eliminate any potential remote openings as a result of the management program that we put in place. This was a large hospital in the Boston area as well, where we go in and there's a chemical inventory program. We go in periodically and evaluate the inventory, QC, going through the laboratories and re-inventorying, making sure that the inventories are up to date. We've also started identifying potential peroxide formers as we came across them. We flagged them in the inventory. They were all tested, worked with the lab staff. If it was something they didn't need, we took it. Able to test the material, flag it before it became an issue, and again, ship it off-site and dispose of it before there was any issues. And this has been another very successful program where we've had no remote openings within this institution since we started doing this program. These programs have been very successful. With that maintenance piece, once the program's been set up, that'll work best for our client and working with our clients. Been able to have an excellent success rate with really eliminating any potential remote openings. And let's kind of move out of the New England area within in New York, a research manufacturing institution we do work with, that we did a walkthrough of the facility. We identified any potential peroxide forming materials, any of the materials that they were no longer using. Everything was, we tested some of the material. We did have to initially remote open, but we tested the materials after, removed any of the materials that were an issue, or any materials that they didn't need anymore. The materials that they wanted to keep once they were deemed safe, we would put them on a management program. We're checking in every 3 months, materials being tested, and once it expires, the material will be disposed of. Since that initial walkthrough coming in, we've been able to, and that initial remote opening, been able to, again, eliminate any potential remote openings with the management of the program. Then another, down the coast, the Baltimore area, We came in, started doing work with the client, chemical inventory, reviewed their chemical inventory, identified any potential peroxide formers, spoke with the researchers, and worked with environmental health and safety as to the need for the materials. Any material that was no longer needed, we tested and removed for disposal. Now we're doing annual walkthroughs while maintaining the chemical inventory, so the material is tracked. Also, we have have that as a review, and that's been a very successful program as well. So once we have the program set up, had a lot of success in working with our clients to really eliminate any of the remote openings, which can be, we can't completely eliminate them. Some materials are, some materials may get missed or found somewhere, but overall the program, we've had great success in working with clients in developing and maintaining these systems, and there is a lot of benefit to it. Again, each one of those institutions has their own internal systems, and we had to kind of work with them to develop the appropriate program, but in all cases the programs have been very successful to minimize, if not eliminate, any of the remote openings of any high hazard material. So there's multiple benefits from safety standpoint, from financial standpoint. Sorry about that. So there's a lot of benefits with that. With that, if there's any questions, please let me know. Thank you very much, everyone.
Thanks, Ted. You're in high demand. That was a great presentation. Look, we've got questions already waiting in the queue that I want to get to, and also encourage those of you that have a question, let this information soak in. Feel free to type it in. We'll get to as many as we can with the 15 minutes or so that we have left. So let's start with the few that came in early. There were some questions around testing, and Thomas asks, when we get back to that sodium amide container you showed earlier in the presentation, how would one test that container for peroxides?
So that's one that we wouldn't test it. We would just base it on color. If there's any discoloration in the material, it's starting to form peroxides. So that you wouldn't need to test the sodium amide. That one would be, you could base on color.
Okay, so it's clear based on that. Got it. And this, I think, was about the same bottle. Paula asks, are the exterior crystals of the bottle peroxides, or is that another chemical, or is it a mix of both?
That is the sodium amide had reacted off. That's sodium hydroxide crusted onto the side. It's one of the byproducts of the sodium amide. So that's just sodium hydroxide crusted onto the bottle.
Okay, got it. Thanks. Another follow-up here. This one also from Paula. Are aqueous solutions of peroxide still reactive with solvents?
So is it reactive with solvents?
Right.
So I mean, I'm not sure I'm clear on the question, Paul. If you have an aqueous solution that contains peroxides and it's mixed with other organic solvents, is there potential for it to form more peroxides, or not really?
That's what it sounds like to me. And we can dive into that further and ask some follow-up. No worries. Let's move on. This one's from Joanne. What are the materials used to stabilize peroxide formers?
There's a few different ways out there, different ways to do it. There is a sodium hydroxide solution that can be used to deactivate peroxides. There's a sulfuric acid, ferrous ammonium sulfate, and water mixture that's used to stabilize peroxides. There's also a new, there's a product that is sold that is designed to dissolve, to deactivate peroxides and the name of the product is escaping me right now, but there's a commercial product out there that you can purchase to deactivate peroxides.
Do you have any favorites, and how do you determine which one you use?
The either the sulfuric acid solution, the sodium hydroxide are the two that I use. I haven't used the commercial product yet, but the sulfuric acid is the main one that I will go with. But either have worked for me in the past.
Great. Well, there's a few options that she can look into. Excellent. Another question asks, what is your recommendation for companies that do not have centralized purchasing?
That's the majority of the clients that we work with, and we found the inventory piece has been extremely helpful, or even if not a complete chemical inventory, if that's something that your institution has. We've had cases where we, gone through the laboratories and with the client and looked for just the peroxide forming materials or any potential energetic materials, and that's the sole purpose of the walkthrough. And we, document where we find the material, what the material is, and that's the one thing that we do with the university in Boston. We don't base it off the chemical inventory. We do a walkthrough specifically targeted for these materials, identify them, their locations, put a report together, present it to environmental health and safety, and then they'll work with the researchers to, the most appropriate way to handle the material. Either they just take it because it's really old and it's disposed of, or it's no longer being used, or it's tested and then it's maintained from that point. So there's a couple different ways to do it. It could be chemical inventory, or it could be just a walkthrough specifically targeting those materials.
Okay, great. And sticking with processes, what kind of processes can produce byproducts or waste that could form peroxides? How do you identify it?
It would really, it's based on what the material, the solvent that's being used. If it's a potential peroxide former, and there's a long list out there. And from a process standpoint, if the material's been purified, really in any way, that's where you get the high likelihood of peroxide formation.
Okay.
Again, there's no inhibitors in there. The material is being run through a system and purified. Just once you get a little bit of air into that system, you can start to get the peroxides, and then it'll just expand from there.
Okay. Here's a good question. I don't know if there's an exact timetable you can put on this, but maybe a benchmark. For the 5 common peroxide formers you mentioned earlier, how long can they be safely used before needing to be disposed, both with inhibitor and without?
So it's there's a lot of things that tie to it. I mean, part of it, there's a couple things. One, there's guidelines. NFPA has guidelines and limits for materials. Also, the manufacturers have their shelf life. But the biggest thing is it comes to how the material is ultimately stored, be it with peroxide, with inhibitor or without inhibitor. If it's stored in a cold, dry place, or if it's stored, that's less likely to have any peroxides versus some place that is hot. It's being opened and closed repeatedly. You're getting that air in there. You're storing it in a warm place. That's going to help with the formation of peroxides. So it really depends upon storage for the material and ultimately how it's handled.
Okay, right. So there's a lot of factors at play. Sure. Ted Thomas wants to know what trigger triumvirate uses or depends upon to identify those peroxide formers that need removal. Is there a certain trigger?
Well, it depends. So, I mean, we'll identify materials that are potential peroxide formers. We will, do an evaluation of the material, test the material, and then make that determination. If the material has peroxides in it, it's not really something. It's most likely not going to be something that the researcher is going to use. It may not be something that environmental health and safety would like to stay on the campus. But it depends upon what the results are of the testing, what the use of the materials is, all those factors. But from an evaluation standpoint, in order to we have to test them in order to make that determination, but also any of the facilities that the material will be disposed of, peroxide forming chemicals are one of the things that they're looking for, and they want to know that the material has been tested. So we'll test any potential peroxide formers after that initial evaluation, just so we have we can say whether or not it has any peroxides for ultimate disposal, or for the client to make a determination if they want to keep it or not.
Okay. And here's a good follow-up from Emily, I think. So when identifying potential peroxide-forming compounds, how can you safely discern if the chemical is safe to open and test on-site, or when is it necessary to remove and do off-site?
So any of the testing we're going to do on-site, it'd just be a difference of if it's done within a lab or if it's done outside in like a parking lot. That testing is going to occur prior to any of the material being removed from site. So part of it is storage, age, how the material, if it's inhibited or not, how the material looks. Like any of the ones in the presentation, that all the pictures of the solvents that had visible solids in them, those were all ones that we remotely opened. Again, if I have one that was received in December of 2015, it's an ether. It's been stored in a cool, dry place. It's only a month old. Inhibitor free. It has a lot of the ethers. They're coming in the liter amber bottles. You can see right in it. It's a clear liquid. It has the Sure Seal. They have that Sure Seal cap on there. There's no air getting in. All those factors. The potential for peroxide formation has been taken out based on the factors that go into the formation. So in that case, that one would be one that would be okay to open and test. And in those cases with the Sure Seal cap, you can extract some of the solvent, and then actually test it onto the peroxide strip to make that determination. So the bottle doesn't necessarily have to be completely open, but it really, again, it ties to a bunch of different factors in how the material was stored and managed, and the age. So it's kind of taking all of that to get into consideration when making that determination. If there's any visible solids, crystals in there, that material is not moved, and it's it's a remote opening, because there's obviously some potential peroxide formation in there.
As a preventative measure, would you recommend in an SOP disposing of anything more than 1 year old? Robert wants to know if this is a best practice you would recommend.
Yes, and depending upon, and there's different guidelines out there, and depending upon the solvent, I mean, a year is a good benchmark. A lot of the potential peroxide formers fall in under a year. Some of there are other materials that are 3 to 6 months, but a year is a good time frame to manage all those materials.
Great. I think you touched on this before, but just to clarify, is there any benefit to storing peroxide formers in a refrigerator, and what are those?
That's the cool dry, the cool dry or a cool dark place. The one thing with that would be, assuming that the refrigerator is rated for flammable materials, but I mean, it just keeps it cool. It's in a dark location. There's, I've seen, we've come across ethers that were stored in a refrigerator that were, north of 10 years old, and they had, some peroxides formed in them, and while it may be stored there, the use is also going to play a part. and if it's open and closed, you're still getting that oxygen in there. Over time, the material is going to, potentially could form peroxides. So it may be so the age is going to play a part. But, that takes the heat out of it, assuming that the refrigerator can handle the material.
Okay, thanks for clarifying that. And we've got a couple minutes left and a few more questions, so let's try and get these done. And if there's anything else, we can follow up later on. So this one comes from Brian. I believe you said dilution is not a valid method of treatment for peroxides. Can you explain this again?
So if I had a 1 liter bottle of ether that had peroxides, if I tried to dilute it down with just water, for example, you're going to get separation of the peroxides, the ether. The ether is going to be on top of the water. The peroxides are going to be at the bottom of the bottle. You're going to, potentially concentrate the peroxides, the deactivation, and it doesn't change the peroxide concentration. It just, if anything, it's going to concentrate it further. So you still have that. From handling and shipping and management hazard, you still have the peroxides there. So to dilute it, you really haven't done anything except potentially made the hazard worse.
Okay, thanks for expanding on that. Thomas has a follow-up to his earlier question. What if a 1-year-old ether container tests negative? How long do you think it can stay after that test?
I mean, it ties back to, not to always hop on back to this, the management piece. If it's managed properly, I've found and tested bottles of ether that have been a couple of years old that were stored properly and managed and maintained well. And they were 2 years old and had no peroxides. So, I've also tested ethers that are under a year old and hit for peroxide. So, that management piece is really the biggest part to it.
That's the key takeaway.
So how long after, it varies.
Okay. Proper management. So Ted, let's wrap up here. One more question, and then we'll close down. This one asks, what materials have a tendency to form peroxides in less than 6 months? Does anything come to mind?
Isopropyl ether and ethyl ether 10. Those are the two most common.
Okay.
That I've come across.
Great, good examples. Excellent. So I think we got through the majority of the questions. Ted, nice job there, and really appreciate the presentation. And I hope everyone was able to take away a few points to help with your own peroxide former management plan. Ted, do you have anything else to add before we start to wrap up? I think there's maybe one more slide at the end here.
No, thank you very much, everyone. And if you have any questions, please don't hesitate to reach out.
Excellent. And as mentioned earlier, we will be sending a follow-up tomorrow. This will include the recording of today's webinar, as well as the slide deck for you to view at your own convenience, and also maybe some other links on some upcoming webinars. We have one on OSHA inspection preparation and preparedness next week. So stay tuned for any upcoming webinars, and feel free to reach out if you want some more advice from Ted or our other peroxide former experts. I think that'll do it for today. Thanks, everyone. Appreciate your attention and your participation. Some great questions, and we'll see you soon. Take care.
Thank you.